We already covered how to actually go about creating a sample app and what the different classes that are created by default as part of a sample app do and why they are present. For example, we talked about the fact that there is a launch screen, and the moment you go about launching an app, first you see the launch screen and then you land on the main app. And we saw that this actually is true for almost all functions which are present or all apps which are out there in the App Store. They all have a launch screen and then the main app is actually launched. We now will try and focus on one individual element, which is what are the application life cycles that are involved, not from the perspective of just classes, but also what all options are there or what all notifications we can receive and customize based on the life cycle stage of an app. Because as we are seeing right now, the app was in foreground and then the app went into background. So there can be multiple actions that are actually occurring for the app as we are interacting with it. And those are the application life cycles. For example, I launched the target app. Now the app is in the foreground. I put the app in background. Okay, so the app is in the background now. Now, if I launch it again, I don't see a launch screen because the app just enters foreground. But I can definitely go about and kill the app, and the app basically gets killed. So we need to know is that what all is happening and what all we get notified upon so that we can go forward and do some custom actions there. Let's look at the application lifecycle. Now, this is a set of classes which we talked about in a previous video where we talked about what these classes do. Here we'll focus on the right hand side. So first of all, as soon as you launch the app, this is in unattached state, which is yes, you have taken the action, the app is going to launch and occupy the screen, but there is nothing which is really happening. It's still supposed to pick up the binary content and start executing. The next stage is foreground inactive, and that's the point when you basically start seeing the contents of your launch screen storyboard. The screen storyboard has been loaded, and you can see its content on the screen, but the app has not been fully initialized. It does not have access to all its bundled resources currently. Then the app UI will actually get loaded. All the resources required by the app would have been initialized, and the app would come into foreground active. From app being in foreground active, the app will transition to foreground inactive the moment you actually try and move it to background mode or into the multitask mode. Then the app enters foreground inactive state. And this also happens when, let us say, there's some notification that comes on the screen, or maybe you received a call while you were actually using the app. Now, eventually, if you actually take action and you take up the call or you go forward and move the app into the background, then the app does enter the background and goes into background state. Now, app can continue living in the background state. Apple keeps changing the rules around what all the app can do in the background, and it does that to protect the battery life, which is a good thing for consumers. But it also means is that eventually the app, if it's there in the background for a long period of time, the OS can decide that it's no longer needed and actually can, first of all, suspend any actions that are being performed. And generally, it's very quick. Like unless you have configured the app to run in the background mode, where there has to be some action like a significant location change. If that's not happening, the app will go to suspend state pretty quickly. But if it's there for a long period of time, you can actually go to the unattached state as well, which is if you go to multitask view, you will still see the screenshot of the app, say as if the app is there. But if you click on it, you will realize that you're seeing the launch screen again. And if you're seeing the launch screen again, that's one hint to you saying that, okay, the app was not really running in the background. It was now unattached. And as a result, the whole launch sequence initialization is actually occurring again. Now let's jump in to the source code files and see what exactly is happening. Now we had created the sample app. It was pretty basic. It would come up with a launch screen, which used to be uh, pink in color. And then you will see the blue, which with the hello world on it. All good. Now, if I want to figure out what exactly was happening during the time frame, first is that I need to go to multitask view. And I can do so by double clicking the home screen. and I enter the multitask queue in the simulator, I can swipe up just like on the real app, and I can actually go forward and kill my app. Now, I have here app delegate and scene delegate. There are two different delegates which are present. For people who have been coding on iOS for some time, point in time before iOS 13, the main source of truth used to be app delegate. There didn't used to be any scene delegates, but now there are scene delegates which are available. And be after iOS 13, if you actually go forward and create an app, by default, a scene delegate is going to be getting created. And the reason is that um, iOS now supports multiple apps running at the same point in time on the same screen, primarily on form factors like iPad, and it's actually allowing multiple instances of the app to get executed, which is think about notes. If I'm using the Notes app, generally I have one instance. If I'm typing, I will type something, and then after I read a different note, I will have to go back to the different do using navigation, come out of this current note, go to the note second note, and then go forward and edit it. But now, if the nodes support multiple instances, you can have two instances of the node open at the same point in time, and you can keep editing them without having to navigate back and forth between them. The example for the same is actually listed on the Apple's website itself. So it's an example of an iPad screen. You can see there are two nodes which are running, and they're running two different node files, but you can go forward and edit them simultaneously as needed. And that's done using scenes, because app delegate used to handle the app level application lifecycle methods. The scene handles scene level application lifecycle methods, and the difference being is that an app can have only one instance. If you kill the app, that app is probably gone. But there can be multiple instances of the app which is running at any given point in time, and each instance is basically a scene. So you launch the app launches and attaches a scene to your app. And then that scene is actually being displayed. And each scene can have different lifecycle method. For example, I may decide to send the node on the right hand side into the background mode, while this node on the left hand side remains active and remains in the foreground. So the scene now has an application lifecycle methods or a scene lifecycle methods rather than the single instance version of the application lifecycle. And we're going to have a deeper dive into them right away. First thing is where is this scenes configured, and how do I configure this multitask or multi uh, split screen functionality? Now, the scenes are basically supported by entering the configuration info or playlists. It's created by default if you have created the app in the latest version of Xcode. If you expand it, you will see that okay, the enable multi windows mode is actually set to no, and it means my app does not support multiple windows, but then there are apps like Notes which might be supporting it. Now there are scene configurations which are actually listed here, and with the scene configuration, the application session role is the one which is going to be defined for the default instance. If your app does not support multiple instances, it will support application session role. And then the configuration name that you want to specify, you can choose the default configuration. You can specify what your delegate class name is, and as you will see, I am using scene delegate. By default it's use scene delegate here, so that's the scene delegate which is present here itself. And it also talks about what is the main storyboard for that particular scene. Again, scene is just not one piece of the UI, but scene is one instance of the app. Now, this gives some confusion to some of the developers because they try and think of scene as something that's just appearing. But think from this perspective that, like objects, you can define an object which is like a student object, and then a student object can have multiple instances. Alex, Susan, Jackie, they can have multiple instances of the student object. Similarly, you have defined your UI storyboards, and then you can provide access to multiple instances of your UI within the application so that they can be run independent of one another as totally different scenes that are executing. And you may support multiple app instances to run simultaneously. You can support something like multiple windows. And one popular instance of this is that push notification. When a push notification comes up, you probably want to run a different scene than a default launch of the app. Or maybe when you're coming from a deep link, you want to launch a different instance of the app, and you can specify those configurations here. Or you can do that inside your app delegate as well. Again, um, between the if you look at the original life cycle from attached to the launch screen be presenting and then it going to foreground active, the app still need to finish launching. So the will finish launching with option and did finish launching with the options would still be called on the app delegate itself. Now the app delegate is also going to honor in the info or playlist entries of the scene configuration. And like I said, okay, application session role is the default scene that has been configured. So it will be honored. At the same point in time, you can go forward and provide custom configurations. So for example, if in these methods like did finish launching or when push you receive push notification and it was launch was because of the remote notification or for handling the deep link, then you can go forward and pass on that information or set the information in app delegate and then use that information for configuring which scene actually gets loaded. And you can specify the scene configuration here. Here by default, we're using the default configuration, but you can go forward and change and specify different scene configurations as you need. For now, we're going to start simple and we're going to go forward and just start looking at the life cycle methods that are going to call when I launch the app. And this is again a fresh launch of the app. As you would have seen in the simulator, I have killed the app. So I go forward and again, I'm talking about scenes at this point in time. So I'm going to put the breakpoints in will finish launching and did finish launching. You see will, as the name suggests, is called just a few milliseconds before did finish. So you see will happening first and then dead. And then you will see that, okay, it will go forward and carry on into the functions for the scene configurations and the scene did disconnect will not get called. It will just get called when the scene actually disconnects. Now, there are other methods that are actually present, like, okay, fine, we finished launching, but at some point in time, I have mentioned in my application lifecycle that the application will become active. So when will that happen? Now, here's what we're going to do. I'm going to put the same method signatures in app delegate as well as scene delegate. And we're going to see and observe which one gets called. And I think I've given the spoiler alert already, which is to say that, well, scene delegates will get called, but let's still check it out. Okay. So I will start with, okay, it will be the application become active. And again, we'll use the trick which we know. We just need to type whatever we know, like a few keywords, and then the autofill from Xcode will take care of the rest. And this function will return anything, so I don't need to worry about any return types here. So application did become active. I'm going to go forward and code the same in scene did become active. Okay, so I'm going to code the same in the scene delegate as well. Now, I also know that after it has become active, right? But did become active should come after the application has entered foreground because as I can see in the life cycle, it was foreground inactive first before the application did became active. So let's go forward and put in a call for enter foreground. Okay, all good. So we put enter foreground. Okay. Now, at some point in time, the application will resign being active, and that's when we talk about some notification coming on top of the screen, call coming on the screen, or you putting the app into the multitask view. And the application will enter background or did enter background when we actually decide to put the application into the background. And then the application can terminate at some point in time. So I will just pass on the will terminate. So I have written all the lifecycle methods. I'm not doing anything in them, I'm not even printing anything, and I'm going to use just breakpoints to stop the code there so I can analyze them rather than putting the print statements. Now in the scene here, I did the did become active. Okay, but we know there has to be something for foreground. So scene will enter foreground. Okay, so we did do that. And if did become active, then we know that it will resign from being active as well at some point in time. So we'll put a breakpoint for that one as well. And we know that, okay, it will have did enter background as well. So I put that for the scene as well. Now terminate is for the application, not for the scene. So I'm not going to worry about it. Let's go forward and run the piece of code and see which one get called when. So first one will finish launching with options gets called, and that's pretty much expected. So all good there. Then I see that my did finish launching with options get called. So that also makes sense. Next one, okay, I'm getting connected to the scene here. So okay, that sounds good as well. And now you see that the scene will enter foreground gets called. And it was not the app delegates app will enter foreground, but it was a scene because it's the instance of the app which is configured to run. And that is true from iOS 13 onwards. You hit the next button, and then eventually, once it enters at the background foreground, then eventually becomes active. So the sequence does make sense totally. First of all, the application notifies that it's about to finish launching with options. Then it actually notifies that it actually has finished launching with options. Then it goes forwards and attaches a scene, and then the scene notifies that it's about to enter into foreground, and eventually the scene does becomes active. So all these lifecycle methods do make sense, and we have documented them here as well, and I've documented from the app delegate perspective rather than the scene delegate. But like I said, okay, both are currently being used. Legacy apps are still using just the app delegate lifecycle methods. But after iOS 13, everything has to follow the scene delegate logic. And I will show how you can go back to the app delegate logic as well in a minute. Okay. We downloaded, okay, certain activities are going to occur when the application enters foreground. And we know that will finish launching with options will get called, did finish launching with options will get called, and then we will move on to our scenes, and the scenes will call, will enter foreground, and then did become active. Let's see what happens when the app goes into background. And the easiest way of doing that is just press the home icon, and the app has entered foreground, and you'll see that it will first resign being active, and then it will notify that it did enter background. And you see both the functions getting called. Okay, all good. Now what happens when the app comes into foreground? You will see the same thing, that the application will did become active, scenes did become active will get called, and then will enter foreground will get called. So this is both getting called, will enter foreground, notifies that it's about to enter foreground, and then it did become active. So application is active now. Now what happens when I go into the multitask view? So let's say swipe up from the bottom. So I do that to enter into the multitask view directly. When I enter into the multitask view directly, you see that it costs scene will resign active. Okay, so because okay, it's going to the multitask view, it knows that it's going to resign being active. But when I hit the play button, I never see the did enter background get called, because this is not considered as being entering the background. It's just notifying that will resign being active. When I bring it back up, then the will enter foreground did not get called this time because it never entered background. So it's not going to enter foreground, it's still in foreground. And you see just the scene did become active getting called. Now, what happens if I just go forward and terminate the application? So let us say I went back, I put the app in the background. So I will see design active and did enter background this time. Now I go to the multitask view, right? And I go forward and kill. I wanted to kill the application, but I decided I accidentally clicked the foreground. So I'm going to skip past that, go back again. And now I'm going to double click to go to multitask view. And I am going to go forward and kill the application. So when I do so, you will notice that nothing in the scene delegate got called. What happens is that your application will terminate, can be called by the OS, but again, you cannot really put any hook when you're killing the application which was running. You really don't have any hooks to actually put into place, and that's what I wanted to demonstrate by doing that. You can go directly into the multitask view here, and you can go forward and kill the application, but you really can't really write the code saying that, okay, I've been force killed. And nothing in scene delegate will be getting called, but application will terminate, can get called when the application is about to be terminated. If you want to store something to the defaults, that's good enough, but you can't really make network calls at that point in time. So that was pretty much about how the application lifecycle works. There's an app delegate and then this scene delegate. An app delegate represents the entire app. The scenes represent individual instances of the app. And there can be multiple instances of the app as different scenes that are running. The app delegate will notify with will finish launching and did finish launching. And then the control will be passed on to the scene delegates, which will receive the lifecycle methods, which are still application lifecycle methods and not the control lifecycle methods. And they will include the fact that the scene is about to enter foreground, which is will enter, or scene did become active. And then when it goes into the background, about to go into background, it gets scene will resign active, and then eventually did enter background. All good and dandy. Now let's look at that. If my scene configuration was not there, how things would be. So let's go forward and delete my scene configuration, which were originally created, and let's go forward and hit the play button. Let's see what's going on. And now I see that I still get my application lifecycle method called will finish, did finish. And when I hit the play button, it's a blank screen, nothing comes up. And why so? There's no configuration for a scene to be connected, and that's okay. But why I'm not seeing any screen or anything on the screen? And the reasoning lies in the fact that um, in iOS, the whole structure of the view looks something like this. And we're going to cover this in more details when we talk about navigation controllers. But you have, like, when you launch the app places a window, and a window doesn't contain any UI controls on it. It's just a placeholder. It's a window where other widgets can be placed. So the window is actually created and placed by iOS. Now, on top of the window, you can have your navigation controllers or your custom view hierarchy. You iOS will go forward and on top of the window put the root view. And then to the root view, you will go forward and add your subviews, which can be your custom view hierarchy, your navigation controllers, and eventually everything is assembled and the assembled view is displayed. And when you were using scenes, then you would notice that under scene delegate, you have the window stored property that is defined, which is an optional. Now that is missing in app delegate, and as a result, there is no window which is present for it to actually render the content. It was only present in scenes. The instances of the app each had their own window, and then in those windows, they were showing their particular instance of the app, like the left screen and the right screen. Here, there is no window for it to attach the root view or the subview store. So we need to go forward and define the stored property for window. And also, once you define the stored property for window, you need to go down and you need to comment out the delegates which you had written for defining how the UI scene session looks like. You comment that out. Now you are in the legacy world where you really don't have define you haven't defined any different scenes, and you have the app delegate which is functioning. So you see launch screen comes up, calls will finish launching with option, then did finish launching gets called. But this time the did become active is getting called on the app delegate and not on the scene, because now it's not a scene based application. You can go forward and go and call the home screen, and when you do, you see application will resign active and did enter foreground gets called. You can go back and launch it, and once you do, it will enter foreground and did become active gets called. So same set of methods gets getting same get called, but this time they are all in the app delegate rather than inside the scene delegates. And as you can see, did enter background get called and will terminate also got called. So lifecycle methods getting called, and it's simple to switch between the two. But again, if you're using an app and you're developing it from scratch beyond iOS 13, then definitely makes sense for you to make leverage scenes and maybe provide capability to support different scenes. Um, that's all that you need to know about application lifecycle methods. Now, they're very useful and you'll be using them a lot because you will need to know is sometimes is why was my application launched? It was because the user tapped upon it? Was it that the user did a 3D touch on the screen and then launched it, or the user came in through a push notification or through a universal link or a deep link? So that information is important, and then it's also important to know when the app entered into the background because you may want to record when your app was put into the background, or you may want to just change the current screen and do note that whenever your app enters background, then iOS takes a screenshot and saves it locally. And if you're a secure application, you may not like it. You may want to replace it with some sort of the launch screen splash so that that's what's getting saved on the iOS system and not basically whatever screen the user was actually viewing. It's also very useful because you may want to do some pre-processing for the user when the app is brought into the foreground. Like if the app is brought into the foreground, you may want to make a refresh call because there may be a latest news if you're a news app or a latest deal if you're a deals app, and you may want to check for freshness when the app enters the foreground. With that, we'll finish the topic on application life cycles, and next we'll move to controller life cycles.